let's see if we can figure out what 3/4 minus 5/8 is. And we have 3/4 depicted right over here. You could view this entire bar as a whole, and we see that it is divided into 4 equal sections, and that 3 of them are shaded in. So those 3 that are shaded in, those represent 3/4 of the whole. So you see that right over there. And then this bar down here, you could view this as another whole. This is another whole right over here, and you can see this divided into 8 equal pieces, and 5 of them are shaded in. So that represents the 5/8. So we want to have 3/4, this green shaded area, and we want to take away the 5/8. So how could we do it? And even when you look at it visually, it might jump out at you. Whenever we add or subtract fractions, we like to think in terms of having the same denominator. Are we going to deal in fourths or eighths or sixteenths or whatever else? So let's think about having a common denominator. And a good common denominator is going to be a common multiple of the 2 denominators right over here, and ideally their least common multiple. And one way that I like to tackle that, there's many ways to do it, is look at the larger of the 2 denominators, look at 8, and then keep looking at increasing multiples of 8 until you find one that's also divisible by 4, perfectly divisible by 4. But with 8, you immediately say, well, 8 is divisible by 4, and it's clearly divisible by itself as well, so 8 is actually the least common multiple of 4 and 8. So you can rewrite both of these fractions as something over 8. So the 3/4, you can write it as something over 8, and then subtracting from that, the 5/8, if you want to write that as something over 8, well, that's just going to be 5/8. And then you can figure out your actual answer. So how can we rewrite 3/4 as something over 8? Well, there's a couple of ways to think about doing it. One way, look, I had 4 in the denominator. Now I'm going to have twice as many equal sections. I multiplied by 2, so I'm going to have twice as many of the sections actually shaded in. So times 2, 3/4 is the same thing as 6/8. And we can also see that visually. If we're going to have twice as many equal sections, here we have everything in fourths, but I'm going to turn this into twice as many equal sections, so I have eighths. So let's do that. So you have this right here. Let me divide that. Let me divide that. Let me divide that. And then let me divide that. And now I went from fourths to eighths. I have 1, 2, 3, 4, 5, 6, 7, 8 equal sections. And we see that 6 of them are shaded in, that 3/4 is the same thing as 6/8. But regardless, now we can subtract. We have 6/8, and we want to take away 5 of the eighths. So we have 6/8, and we want to take away 1, 2, 3, 4, 5 of them. And those 5 of them correspond to these purple 5 right over here. We're taking away 1, 2, 3, 4, 5. We're taking these away. So if you're just looking at the green, we started with 6/8. We're taking away 1, 2, 3, 4, 5 of them. And you can see that corresponds to the 5/8 down here. And what are you left with? Well, you're just going to be left with this 1/8 right over there. So it's just going to be 1/8. And you can see that numerically up here. If I have 6 of something, in this case it's 6/8, and I'm going to subtract 5 of that something, in this case 5/8, I'm going to be left with 1 of that something, or 1/8.